Hi, I'm Swaroop, and I'll be presenting our IoT project, which is Raspberry Pi based smart infant monitoring system, and my teammate is Darshan. Um, we chose this project just because we thought we could be exposed to many different technologies, such as we are building an Android application. We are working through cloud messaging. We are working on machine learning algorithms. So that was the main drive of selecting this project. And as the introduction goes, we thought of building a smart monitor system for the parents to keep monitoring on the infant so that if there is any cry which implies some kind of trouble, or just to monitor what the infant is doing. So we wanted to build this system. Um, and for this system, we are using a Raspberry Pi controller as our primary hardware, which has an integration of camera and microphone, and also a mobile to for the mobile application. So this is the control flow of our project. So we are using a Raspberry Pi for the server and uh, so we're using Raspberry Pi for the server side service, and with that we have sensors such as a microphone and camera, which is integrated, and then we have a Firebase console, and then towards the client end we have a mobile application. So the control flow goes like this. So once we capture the audio from the microphone, we process it, and every 5 seconds the audio is processed and passed through the cry detection algorithm. And based on the output of the cry detection algorithm, if it's a cry or not, if it's a cry, we'll be triggering a notification to the Firebase console, and which in turn pushes a notification to the mobile application, and the user gets notified as in where there's a infant cry, and he has an ability to choose whether he wants to view the video stream or not. Um, and that is how um, parent can monitor the infant. So yeah, the data flow goes the same way. So as I said previously, so, we'll be recording the audio and running the cry detection algorithm every 5 seconds. If it's if the cry is detected, yes, we'll be sending the notification to Firebase, and the mobile is and will be receiving the notification, and user decides whether to view it or take any action. So these are the hardware components, as I said before. For the software end, we are using Raspberry Pi OS for the Raspberry Pi module, Python language for most of our programming, Java for Android Studio, Android application, and TensorFlow machine learning library for the convolutional neural network, and Firebase for notification, and Python socket server for video streaming. This is just a concept of cloud messaging in Firebase. For the cry detection algorithm, we are using a convolutional neural network, um, using a TensorFlow library. So we are training our model with three different labels, which are noise, which is external noise, silent, which is mute sound, and and baby cry. So this is where we go through the code. Mm. So this is our Git repo, which we are maintaining, and we have all our code synced in here. Um, these are the files on the server end. The CNN is the model training convolutional neural network file, which has the training with three different labels, and we have trained the model, and this is the model file which will be importing and the importing and predicting the values for the new audio file which will be recorded. And trigger.py is the file where we have most of the implementation of our our uh, timer, our recording of the video and audio streaming. So these are the libraries which are we imported, and we are recording for like every 5 seconds, 5 seconds, and then we're processing it. And this is the chunk file for the buffer for the audio, for the unequal sized audio files, which we will be padding extra the remaining values with. This is the server token and the device token for the Firebase notification. These are the headers and the body which will be sent sent to the in the notification, and this is the payload data. And this part is for the video streaming. Um, the As soon as the camera is it is the Raspberry Pi camera is activated, it starts streaming the video with the help of this, and it'll be streaming writing the mm, we'll come back to this later. Yeah, this part is the this part is where we send the notification to the users through Firebase. And This is where we start streaming the recording the audio. Once the audio is recorded for 5 minutes, we'll be we'll be making it to the WAV format file, and then we'll be loading our classification CNN model and trained model, and we'll be predicting the values, whether it's which class label it is. Based on the class labels, we are deciding whether it's a cry or not. Once the once it is detected as a cry, we'll be start streaming the video. And once the user on the mobile end switches it on, he can view the video. And this part is where we are handling the video and writing it to the socket. So we'll be going through our convolutional neural network implementation, as since this is our crucial feature. So these are we are using Keras for this convolutional neural network implementation. And what we do is we are importing the data set from our local machine, and it is imported, once it is imported, we are loading the file. Once we read the files, we'll be passing the files to the Librosa, uh, and loading the files through Librosa, and we'll be converting the audio file into the mel frequency septal coefficients. Um, then we add a padding around it, which are less of length, and we'll be adding padding for it to make it of equal length. And once we have that, we'll be splitting the data into train and test. Since CNN is works on image classification, the mel frequency, it classifies using the MFCCs. And our model has 14 layers, which is a convolutional layer, and max pooling, which involves shuffling of the data samples, and taking the maximum out of it, and a dropout value, which helps in reducing the possibility of overfitting by dropping samples. And as the final layer, we have the softmax layer, um, which is a prediction layer. And once we once we have our model ready, we are training it with the 25 epochs. We and Once it is trained, we evaluated the model using the test set, and we got around 85 percent of accuracy. And that is it for the CNN model. So now we'll be going through our Android code. Um, we have a simple implementation of having Firebase notification notified, and watching the video stream from the mobile app. And this is where how it goes. This is the main activity where a user lands in when he uses the app. And we once he has logged into the app, we'll be initializing the Firebase token for each user, and we'll be sending it to the server. And then once the notification is fired, the notification will be handled on message received of the Firebase library, and then of the Firebase library. And once the on message received is triggered, we'll be getting the payload out of it and broadcasting it to a local broadcast manager, wherein we catch that local broadcast here in the main activity, and we'll be showing a dialog saying infant cry detected. And once the user wishes to click yes, he'll be viewing the video stream. So that is all for project implementation and demo, and thank you.
Hi everyone, today I'm going to demo you our project that is cry detection for infant monitoring. Here I've connected my Raspberry Pi to the monitor, and I am viewing the Raspberry Pi screen as you are seeing it. I've opened the terminal, and also I have installed all the modules which will run on the Pi for my cry detection algorithm, and those will run on the virtual environment. Since you can see here, EVN is the virtual environment of the Raspberry Pi, and I'm going to show you. This is our code structure. The trigger Pi is where we keep the source code, and the job will run the trigger.py. Yeah, this is about it. And this you can see, these are we have mainly used Python for programming. That's it. Now I'm going to run the file and show you. Yeah, now I'm running the Python trigger file which I mentioned to you. Yeah, now I'll start recording for the cry detection, and I'm also owning a baby cry. Yeah, it has started to record. As you can see, we have detected a cry here, and it has sent a message to the device here, and I'm going to on OK for that. And see, I'm able to connect to the Pi, and then able to view the screen. This is one of the operations which we are performing, and I'm going to demo you the other operation later.
Now we'll be showing the other scenario where the cry is not detected. We're running the script now. Then it starts recording the audio, and it goes through the model, and since you can see, as you can see, it is predicted as class 1, which is nice, and it is not a cry, and it's not detected, and the phone will not receive any notification.